Hi everyone. Today I'm going to discuss about generative models. What is the difference between generative and a discriminative model? In discriminative model, what we're trying to do is we are trying to learn the probability of the label given the data, which is probability of y given x is equal to x. What does that mean? So let's take an example of logistic regression or linear regression. We already have the model as a linear equation. What we try to learn is the weights through the given data, which will give us the probability of the label. But in terms of generative model, what we're trying to learn is the joint distribution. So once we have joint distribution given the data and the label x and y, we can use a conditional probability formula to either derive x given y or y given x. I thought I'll take one example, which is naive Bayes classifier, and implement it in the Python and see how the generative model works and why is it called generative and how are we actually learning the joint distribution. So the model that I took is a Gaussian naive model. Once we have the term Gaussian, I think it's pretty much implied that we are going to learn about we are going to get the mean and the variance of the feature of a model. And as the term naive says, we are going to consider each feature as independent, so that when we try to learn the joint distribution, we will just multiply the probability of each feature. I'll show the formulas pretty soon. So the data set that I took is I'll put the link in the video. So it's a data set that explains if a person is diabetic or not based on the parameters, 8 different parameters it's here. So the first step that I do was, since it's a Gaussian naive Bayes model, as the term Gaussian says, I'm trying to learn the mean and the variance of each feature per class. So here we have only two classes, 1 and 0. So for each class I'm learning the mean and standard deviation. And for all the 8 features, I have learned them and stored in a variable, and then I'm learning the overall probability of the feature, which is pretty much simple, as easy as odds ratio. And we also calculate the probability of each feature given the class, and this is the formula for that. This is the formula that is used in, this is actually a Gaussian or a normal distribution formula. So we apply that to every feature here, and I have also added some test over here to understand if this formula is actually giving us a probability of a given value and its label. So let's take one example over here. So the first row where the pregnancy has a value 6 and its label is 1. So if I apply that to the normal distributions equation, I should get the value close to 1. So when I use a formula for or use the distribution that we calculated from the subset of data for 1, I get a probability of 0.26, and for 0 I get a probability of 0.09. So it's pretty much shows what the distribution that is already learned for a single feature. And like that we learn for all other features, and then we use this formula to calculate the probability of all the features. As I mentioned, since it's a naive Bayes, we multiply the probability of all the features and their classes. And to find the overall probability here, here is a place where we apply the Bayes theorem formula. But the formulas for each class are given here, and this is a programmatical way of applying the formula. And when I try to test it, let's say we take the second index, which is a patient who is diabetic. So if I apply the formulas and I see the probability that it is 1 is higher than the probability that it is 0. Let's take another patient, the patient with the index 3, who is not a diabetic, and it comes to the result that the probability the patient does not have diabetic is high than he has diabetic. This is a small example to show how it is learning the joint distribution, using the joint distribution to predict the class. Thank you.